Okay, last but not least, we're going to look at our point list data set we just created. We're going to kind of explore that data frame and visualize the metadata behind this point list. So give us a sense of, how many points, do different buildings have? What are the most common types of labels or tags? Really to give you a sense of the big picture of what's in the data set that's in this hackathon. What do you have access to? So we're going to use the two libraries, one called matplotlib, the other called Seaborn. Seaborn kind of like is a layer on top of matplotlib. Matplotlib is pretty fundamental. Seaborn's a little more polished and has some really template type of visualizations, which you'll see here in a second. So the point list itself, we're just going to look at the first point in the point list. We're going to use .t for transpose. We're going to look at all the different columns, or basically the attributes of each point that we have in this data set. We have the ID point, we have the building it's from, the timestamp. This is, and there was previous videos, previous series that showed you how to convert the timestamp. We'll do that in the next set of videos too when we look at time series data, the device, the point name, description, all the different things, equipment type, things about the equipment. So as you can see, there's quite a bit of information here. And down here you have tags, which of course is the set of attributes that you can use to query. So let's figure out the best way to explore this data set in a way to understand what are we looking at here? What are the points and how many pieces of equipment and things. So the first thing we can do is use the .unique function to see how many unique points we have, how many unique buildings. Like I said, we've got 44,000 points from 229 buildings. Once again, this is by far the largest data set for a buildings related hackathon that I've ever seen, for sure, and I've even hosted a few of them. So this is a lot of points. Let's try to visualize what these points look like. Let's look at the number of points by building, so we get a sense of is it pretty consistent across the data set? How many buildings? Does every building have the same number of points? So what we end up with in this chart is the answer is no, actually. So here, there's 229 buildings on the x-axis. So it's kind of smushed together. You can't really see the names, but they're not really meaningful anyway. They're just numbers. You can see that, here's a building here, this number, I can't read it very well, but it's a building that has over 6,000 points. So out of 44,000 points, one building has 6,000 points. That's going to be a good one to play around with. You've got several other buildings. It looks like a handful, maybe a dozen or so buildings that have over 1,000 points. And you got lots and lots of buildings that some have somewhere between, let's say, tens to hundreds to thousands of points. So there's a pretty big diversity of number of points per building. So how is that going to build into your strategy for your analysis? That's something you'll have to figure out, right? So next thing, let's look at the description of the points. So how many, we can use the value counts function. It's really useful when you're exploring metadata. So what are the main point types that we have in this 44,000 data set? So the description is kind of somewhat unique for, so the description is kind of a unique item in the point list. So let's see how many points we have in the top 50 types of points according to description. So it looks like voltage and main power are a pretty common descriptor of a point type. Let's say we want to plot the first the top 10 of these points types, this is actually top 50. We can use this chunk of code here to visualize this. So this is using Seaborn, using a plot type called count plot, where we're looking at description. We're looking at only 50 of the points. We're coloring it crimson. We have our title of our data frame, number of points. We can put the legend. We can show percentages. There's a whole chunk of text here that shows how to make percentages. So you could pick. We picked description, which as a column to look at, but you could look at lots of other of the columns, and you could decompose, like for example, the tag column to be able to do this. So anyway, the point is that here we have a bar chart showing this particular breakdown of descriptors. These are the most common descriptors across the 44,000 points, which can be kind of interesting just to get a sense of what are the main points you're looking at, which seem to be, in terms of the descriptor column, seem to be quite a few power meter points, it looks like. Let's look at the number of points by equipment type and building. So here you can see when you plot this, you're using the count plot again. This time you're using the hue. So you can use other columns from your data frame to divide the visualization, or to differentiate which of the columns you want to use as a differentiator. We're using, we're finding the equipment type per building. This is the visualization we end up with. It's a little hard to read, obviously, because there's a lot of different buildings. But you can see here very quickly that there's a few, quite a few buildings that have air handling units. There's quite a few buildings that have boilers and pumps and site sensors. And you can see down here at the bottom the number of points that you have for each of these. So out of all the, pieces of equipment, you've got the most air handling units, VAV boxes. So it looks like if one or two of the sites has quite a few VAV boxes, up to 500 VAV boxes. So that's going to be a building if you want to do, and you can't really tell right in this visualization which building that is. It's one of these purple buildings, probably the building that has 6,000 points, let's say. But anyway, you get the point. So this is kind of a way to see this from a high level of the number of points in each building. So you can play around with this and tweak and tune the parameters in ways to kind of slice it only in the ways that you want to see what you're trying to see. So it's a little bit, here, pretty messy to visualize, but it makes a point. You can visualize things at the same time. So next, let's look at tags. So we look at all the different tags. What we can do is concatenate the list from each row. Here we get the point types. These are the first 10 point types of tags. We can create a tags point list. We can use the count plot to look at the most common tags in the data set. So HVAC is really, really common. Over 80% of the points in this hackathon are HVAC related. Not a big surprise. Over 25% of the points are related to AHUs, 21% are related to VAV boxes, and you got 8.8% fan coil units, RTU rooftop units. So this is a pretty common American style HVAC data set where you've got lots of air handling units, VAV boxes, and fan coil units. For those of you who don't know, air handling unit is kind of a centralized system. Fan coil units and VAV boxes are what's called terminal units that are downstream of the centralized system. So this is great. This is a great visualization to show you that the types of data that you have in this data set in the hackathon, which is mostly HVAC from different types of units. It does look like we have some water side systems here. We've got chillers and pumps and boilers and things, but the percentage, out of all the points, only 3 to 4% have chiller, pump, boiler tags. So if you're looking at something at the plant level, at the water side level, primary systems level, not as much data there, but still probably a fair amount. Look down here at the bottom, number of tags. So still hundreds or even thousands of tags from those systems as well. What are we going to do next here? We're going to, create buildings, unique buildings and unique points. And then we can create a visualization that, in this case, we're just going to look at 5 buildings. So instead of all 229 buildings, we're going to look at just 5 buildings. And here you have a big chunk of code that has different sectors to it. It's going to have actually 4 visualizations patched into one visualization, which is really common when you use pandas. So here we have 5 buildings, and you've got, one of the buildings has over 1,200 points. The other 2 buildings, other 4 buildings, one has close to 400, and then you have a few buildings with less than 50 points. It looks like when you look at these by equipment type, you've got the building with a lot of points has site sensors. That's interesting. Not sure what site sensors are, but they seem to be pretty common with that that building. You probably have to dig into the tags to figure out maybe exactly what that means. Well, site tag is the most common tag out of these 5 buildings. Here you look at the descriptors. It looks like there's a few, and descriptor is seems like to be a pretty unique identifier of points. So here you can see that there's quite a few points that have basically the same number of descriptors. So it's not, this upper right hand corner is maybe not quite as informative. But anyway, you kind of get the point. Like, you're visualizing, in this case, these 5 buildings. Maybe you want to take and filter the data set according to the buildings that have certain types of equipment, and then visualize them in this ways. Really, this is the first thing you should be doing in this data set, is exploring the metadata. And then using that as a foundation for what question you're going to ask, and I'll show you some examples of questions you can ask in a few sections from this. So thanks a lot for watching these videos. Explore that data, look through the data. The next set of videos, I'm going to dive into showing you how to play around with the time series data, because the metadata of the point list is the first part. Then the time series data, that's where you get into the different aspects of whatever your solution you're proposing in the hackathon might be. So thanks a lot, and see you in the next set of videos.